Buenos días a todos. Disculpe, pero mi español es no suficiente para presentar, por eso voy a continuar en inglés. Okay, once more, welcome to a topic which is not 100% about tunneling, but you have a TBM and maybe you have to pass through what we show here, because it's now about the construction of a metro station. And this has been done in a rapid tempo for the Olympics. The Metro de Río de Janeiro, Línea 4, about the station Jardine de Alah. For those which are not familiar with the main technique, I will give you a brief introduction in the procedure of the technique, and then of course we will move to the installation and the job site. So a little bit in general about the procedure. We are talking about diaphragm wall installation using a trench cutter system. And when we look to the system, how does it work? First of all, we need to do a small pre-excavation inside a guide wall before we can launch the trench cutter to install and to excavate the trenches. Usually the excavation takes place in a single or multiple bite as shown here. And as soon as we have finished the installation or the excavation, we insert the reinforcement cage and start the concreting process. Usually you do a number of primary panels as shown here, and then you come back later and install secondary panels. The secondary panels will cut into the primary panels, and due to the shape of the cutter wheels, you have a kind of an interlocking system which ensures a good contact and a watertight joint. So that means with all the secondaries, you close the gaps in between the primaries and create the continuous wall. We have two important sections. The one is the excavation, and to support the excavation, we need a support fluid. It keeps the trench open, it prevents from collapse, and in the specific case of the trench cutter, it also transports the soil and the rock which we excavate through the lines. And also the lubrication of the material gears somehow reduces wear and tear. Typically, bentonite or polymer slurries are used, and I want to mention that there is a guide for support fluids for the deep foundation, which is a joint effort between the American Deep Foundation Institute and the European group of foundation contractors. So they really put in their working group all the knowledge together with all the disciplines to make the industry better. It's free available on the DFI or the EFFC webpage. So this can guide you through all the, let's say, informations you require for the design, for the properties, for the execution, quality control, and whatever is required for using a support fluid. In the second part, after we finish the execution, of course, we have to reinforce and to concrete. And for the concrete, it's important to have a proper tremie guide, tremie pipe, to ensure a proper, let's say, concreting process. And of course, concreting is quite an important issue. The concrete is quite important. So this is, especially when you go for deeper concreting sessions, the concrete properties for workability, stability, self-compacting is quite important as well to avoid any problems. And also herefore, there is a guide available. They are already in the second edition, so they gain already more experiences. And again, I can recommend whoever is interested a little bit more into these topics should download these of the homepage, and it's set for free. Yeah, to execute the work, of course, we need some equipment, and here we see various types of so-called hose handling systems, either on a crane-based system or on a mast-based system. And depending on the slurry hose system or on this hose systems, you can achieve higher depths. The biggest depths you can gain with a hose drum system, which you can mount either on a base carrier as a drilling rig or on a crane. And with a system of a hose drum system, we are actually able to reach depths of up to 250 meters. Of course, the key component is the cutter itself. And when we look to the cutter a little bit more, we have some steering plates to guide the cutter in case any kind of deviations occur. We have a mud house inside, and as said, we cut the soil with the cutter wheels. They are hidden here for special reasons. They are at the bottom. When we lose the material with the cutter wheels, there is a suction box on top. The suction box acts like a Hoover cleaner and removes the loosened soil together with the slurry via the mud pump and the mud hose. Of course, we need to know how the cutter wheels look like, and there are various types of cutter wheels existing. We have standard wheels for any kind of soil conditions, and we have various types of wheels for rock and very hard rock conditions. So whatever you expect in your ground conditions, you can adjust your wheel types. Unfortunately, we cannot change the wheels like Formula One. It takes a little bit longer, but it's reasonable time. Altogether, it is somehow in a circle. As said, when we lose the material with the cutter, we transport the material on the downstroke through the slurry pipe, through the hose, and we pump it to a descending unit. So at that area, the slurry and the material, the soil, will be separated so that you can spoil the material, the soil, and the slurry will go back into the circuit and will be pumped back into the trench, because you won't have an empty trench. You have to have it filled and stable. And so this is a closed circuit. And the descending unit, you can adjust according to your soil conditions. You can add a desilter, you can add a decanter. So whatever is required to have a proper slurry for the installation, you can set it up. So now we know how to do the work. We can take a look to the subway station. The line number 4 was at that time the newest addition to the network in Rio de Janeiro. And it starts in the south at the nice areas of Ipanema and the beaches, going to the west to the Barra de Turca, where the Olympic Park and the Olympic Village was built for the Olympic Games. So everything had to be done until the Olympics 2016. It covers in total 1, 2, 3, 4, 5, 6 new stations. This was already existing. And the whole thing is about 16 kilometers in total length. And the expected cost was about $2.2 billion US. You may ask later what was the real cost. Unfortunately, I cannot answer this question if you think about it. We focus on the most critical and most complicated station, the Jardine de Alah. It's located in an area between the ocean at Ipanema and the lake. And you can already imagine here, you can see already some silos. And we look a little bit closer, it's really in the center of a street, adjacent high-rise buildings. The high-rise buildings just founded on shallow foundations in a saturated sand, and the groundwater table, you can imagine, is quite high, so it's just 3 meters above the ground because it's sea level. And the soil conditions, mainly sand, loose to medium sand, also sometimes compacted, and then we reached a rock, a gneiss rock with a strength of about 150 megapascal. So the original design was to install the station with a dimension of 120 by 18 meters in a, let's say, traditional top-down cut and cover method, here shown with all the various steps. Looking a little bit closer to the design, in the design stage, they considered to do the diaphragm wall just to key or to hit the rock, and then pin all these elements into the rock with some root piles. To ensure the water tightness, they wanted to do after, behind every joint and at the contact zone, a lot of jet grouting columns for sealing purpose, and also a jet grouting plug underneath to ensure water tightness of the excavation pit. Excavation need to be done down to about 24 meters. So it's a quite critical situation. So now there was one big concern and one big problem. The big concern was whether they can guarantee dewatering. When you can imagine you are close to the canal, close to the ocean, so there's a lot of water to pump if the ocean is coming through. Second, there was a time issue. The TBM was, let's say, almost on the way, and they were thinking about how we can accelerate the installation. And so they changed the design in a way that, okay, this is a jet grouting plug. In addition, just forgot that there were also jet grouting walls planned for the access and the exit for the TBM later on. But coming back to the redesign, they thought, okay, let's do directly a diaphragm wall using a trench cutter and key into the rock for 2 to 6 meters without having these root piles. So therefore, they could eliminate also all the jet grouting plugs, but they did a little bit of jet grouting. Here you can see, let's say, the situation quite narrow, everything. Here, now the final, let's say, design or the final way how they executed it. So first of all, as the rock was quite, let's say, varying in depth from 20 to 33 meters, and it was very uneven, they said, okay, to ensure a proper installation during the construction process, we will level the surface of the rock by a small jet grouting addition, just to ensure that the penetration of the cutter can be easier done and easier guided to avoid any kind of deviation. And then, to be on the safe side, as you can see, let's say the buildings were quite close, they said we are only going with the single bite panels, even for the primaries, to ensure that we don't have a problem with trench collapses and settlements in the surrounding area. And then in principle, after they did the jet grouting, they start, as we saw in the beginning, with a small pre-excavation, and then doing the cutting process, doing the reinforcing, doing the concreting, and coming back after a while, doing the secondaries to close the wall. Of course, it was very important to do all the quality control. For instance, the operator of the cutter, he has a real-time control with inclinometers, accelerometers, gyro compass to really ensure a straight installation of the cutter. And as I said, there are some flaps in case the cutter tends to deviate, he can react and can ensure a straight installation. Here you can see also a grab, which was used mainly for the pre-excavation, and on a very specific picture here for the access areas of the TBM, the reinforcement was used with a fiberglass for the entry and the exit, so there was no jet grouting. Yeah, but there was still some jet grouting to do, not anymore for, let's say, the sealing purpose, but somehow they had to pass the canal, and therefore the jet grouting mass installation has to be done to ensure that when the tunnel, the TBM went through, there's a contact for the cutter, for the tunnel lining to the jet grouting. And it started in the canal just below the surface of the canal down to the rock. Of course, you couldn't close the canal. So in this case, they just, let's say, worked or built a working platform inside the canal, a little bit more than the half, and they installed the jet grouting. You can see here a couple of rigs working simultaneously, and then when they reached the half, they removed the one working platform, they moved to the other working platform, and then did the second half. And to ensure that there's really a contact, the center ones, they did twice, one from each side. In addition, just for safety reasons, they did a small jet grouting inside the station, just as a kind of a flood protection, with smaller diameters, only 0.6. The other jet grouting columns were always 1.2, but in principle, just to try to get this wall done in case there is a risk of some water leakage. The jet grouting in general, construction sequence, easily done, working down, drilling down from the top to the rock, a little bit into the rock, and then using high pressure cement grout injection by turning and lifting at a defined lifting procedure, high pressure of about 400 plus bars. And of course, everything is monitored during the installation process to guarantee that there is a full plug. Yeah, finally, a view to the front of the wall, and now we still see a TBM, so we are back to the tunneling, and TBM arrives and passed, and everybody was happy that everything was just in time. And when you talk to the, let's say, to the participants of this project, this was one big conclusion, that the successful interaction between, let's say, all the specific parties, the owner, the authority, the contractors, the joint venture, all the engineering parts and the contractor, say, work together and find a solution to make this project a successful project. At that time, it was the first time that the trench cutter was used to build a station. So it was used for other purposes, but here for a station in Rio de Janeiro. And the total amount was about 233 panels. So 22,000 cubic meter of soil and rock have been excavated. And in addition, 12,000 columns of jet grouting have been installed. So about 110,000 linear meters have been injected. That's so far from my side. So when you have some questions, here's a contact. We are standing outside at the booth. And yeah, passion for progress is our intention. And muchas gracias por tu atención.